In item number 1 on the first exam, we're asked to find a couple of different things, such as the mean and standard deviation for a random variable that is discrete and only runs from 0 to 4. The probabilities of those values are given to us. Anything outside of 4 or larger than 4 is not going to be possible. And so let's zoom in on this and get going on it. So we got that the mean is nothing but the weighted average of the possible outcomes here. We're not going to show every single one of them. We'll do some of them, but the likelihood that we have a value of 0 is 0.6. The likelihood that we have a value of 1 is 0.2. And the likelihood of 2 is 0.11. Well, heck, we're almost there. Let's just do them all. 3 has a likelihood of 0.08, and 4 has a likelihood of only 1%. And when you evaluate that, you'll end up with an average that's exactly equal to 0.7. For the standard deviation, we first have to find the variance, and that is the weighted likelihood of the squared difference from the mean. A much easier to work calculation formula is to find the weighted average of the individual values squared and then subtract off the square of the mean. Right? And so when you do that, you'll have 0 squared times the likelihood that that value is 0.6 plus 1 squared times 0.2 plus 2 squared times 0.11 plus 3 squared times 0.08 plus 4 squared times 0.01, and subtract off our square of our mean, and that will equal about 1.03. To find then the standard deviation, then we would take the square root of the variance, and we'll get about 1.01. So that's part A. The key thing here is the calculation formula for the variance and then taking the square root afterwards. Right? And the part B, the difference here is that we have 3 different production runs, and we only want a total of 2 or fewer defective parts. That's a little bit different than just what happens in one run. Right? So let's define that Y is the total defects in 3 runs. And so now that means that Y is ultimately here equal to the number of defects in run 1 plus that in 2 and that in 3. Right? And so you might think about setting up a table of sorts here. You could do this work by just simple working out all the permutations. There's a very elegant way to answer this, but that involves all the combinatorial math, and sometimes it's just easier to work with enumerating the possibilities. Right? So of the things that we're interested in here, for probability that Y is less than or equal to 2, well, Y can take on 0, 1, or 2 for a total quantity. Those are the things that we're interested in. And so let's set that up. That the only way to get Y equal to 0 is if X is equal to 0 and X2 and X3, all of those are equal to 0. And since the likelihood of each one of those being 0 is 0.6, there's only one combination. That would be 0.6 cubed. Simultaneous occurrence, intersection events, so to speak, of each one of those. Right? The next possibility here is that Y is equal to 1. That can happen, though, in 3 different ways, each ultimately with the same likelihood. So when we go to calculate that one, then we'll have 3 times the likelihood then of one of these sequences, which is likelihood of 1 is 0.2, and then likelihood of 2 zeros is 0.6 squared. And then we have the outcome for Y equal to 2. That could be 0, 1, 1. It could be 1, 0, 1, or 1, 1, 0. And then there again you'd have 3 times the possibility that you would have 2 ones would be 0.2 squared and 1 0 would be 0.6. There's another way to get, though, of course, y equal to 2, and that would be through 2 0 0 0 2 0 or 0 0 2, and now that one's going to be 3 times likelihood of a single 0, that's two zeros, that would be 0.6 squared, and then probability of a 2, it would be 0.1. Add up all of these, and you end up with a final answer of about 0.62. I think it's 6228. Right now, again, there's a nice elegant solution and one that's not only pretty and beautiful, but if you had more combinations to have to enumerate, would be the way to go. But for one that's relatively straightforward like this, you can do it in a straightforward fashion such as this.